today is Heidi Meyer. And Heidi is a longtime math faculty member here at MJC. She, her education was from Calvin College in Grand Rapids, Michigan. She also attended CSU Stanislaus and Western Michigan University. And her talk comes from a subset of topics from a sabbatical that she took just last spring, where she traveled and focused on learning about 500 years of math history. And this is a accumulation of that. So it will be from the Renaissance to the present. So please help me in welcoming Heidi Meyer.
Thank you. Thank you. I just want to point out that there are handouts. I've put a map of my travels, and I've put the pictures of the women that I'll be speaking about. And then on the other side, I wanted to give a timeline, just so you can kind of have an idea of where this falls in terms of history. This is a subset of my sabbatical travels. So, boy, 500 years is a long time. That's a lot of math history. And I studied not only so many years, and by the way, my travels and this focus on history was in Northern Europe. So it wasn't the entire world, but in Northern Europe, from the Renaissance to the present. So as I was thinking about what to pull together for a talk, which stories kind of rose to the surface. And I kept coming back to the obstacles that women had to overcome in the 1800s in math and science. And it wasn't that I was specifically studying women. I was studying not all of the mathematicians, many prominent mathematicians from the last 500 years. But the stories that I'll be sharing with you in particular are stories of the triumph of the human spirit and of perseverance and overcoming, which really spoke to me. As you can see on your map, this is the region in which I traveled. I started in Scotland, went down through England, got to be in archives in various universities, particularly in Oxford and in Heidelberg, moved on into France and Germany. I'd like you to pay particular attention to this city, Göttingen. That's going to come up a number of times in the talk. That was my second to last stop, and it was a major center for mathematics, major world center for mathematics. So the women from this time, some earlier, well, the earliest one, Sophie Germain, was born in 1776, and Emmy Noether was born in 1882. So it covers quite a span of time. My struggle, speaking of time, is how to pace this talk, because I've studied the lives of these women very deeply, and they have become very close to me. And I want to share every detail about their lives, and I can't do that in an hour, so I'm going to have to sort of restrain myself. I will be talking about the three on the top, Sophie Germain, Sonia Kovalevsky, and Mary Somerville, and if we get time, I'd like to share a little bit about Ada Byron Lovelace and Emmy Noether on the bottom there. So we're going to jump in and get started with Sophie Germain. Sophie was born in 1776 in Paris. So the year of the American Declaration of Independence. She was born in Paris, not very far from Notre Dame. She was born up there at 336 Rue Saint-Denis, and later in life as an adult she lived here at 13 Rue des Savoie, so just on either side of Ile de la Cité. Very, very beautiful place, near the banks of the Seine. Absolutely gorgeous, near Notre Dame. So just a very beautiful place to live. But as Charles Dickens says in A Tale of Two Cities, it was the best of times, it was the worst of times, right? If she was born in 1776, well, the Bastille was stormed in 1789. So there we have the beginning of the French Revolution, which is when she was 13 years old. And if we look back at the map, over here, we have the Place de la Concorde, which is where the guillotine was set up during the Revolution and the Reign of Terror. And over here, on Ile de la Cité, where the cathedral is, we had La Conciergerie, which is where some of the prisoners were kept, including Marie Antoinette. So, looking at some pictures of those places, this is what Place de la Concorde looks like now. Absolutely beautiful. Another view Very beautiful, very happy place to be. Not so happy back at that time. And this is La Conciergerie over here. Sophie's family was wealthy. Her father was a wealthy silk merchant. They weren't part of the aristocracy. They weren't wealthy enough to be on anybody's radar in terms of the French Revolution. They were wealthy enough to be able to keep themselves safe. But part of that, in terms of the impact on Sophie's life, is that she needed to stay in the house, right? You can't be outside and be safe. She needed to stay in the house. So she spent a lot of time in her father's library. And at some point during her childhood, she came across a book on the history of mathematics. And she read the story of a mathematician from ancient Greek times. He lived in the 3rd century BC. His name was Archimedes. And you know, we love to rank things, don't we? So even among mathematicians, we rank who's the best mathematician of all time. Well, Archimedes is generally considered to be in the top 3 mathematicians of all time and the top mathematician of antiquity. And he was living at a time, there was a lot of warfare. He lived in the city of Syracuse, which is on the island of Sicily. And this was during the time of the Second Punic War. And the Romans were invading. And Archimedes was a mathematician, an inventor, an engineer. He had developed a lot of things that could be used in warfare, things such as giant mirrors where they could reflect the sun's rays onto enemy ships and burn them and things along those lines. We're not entirely sure these days how much of that is legend and how much of that is true, but he was certainly very well regarded. To the point where the Roman general said to his soldiers, when you find Archimedes, bring him back alive. We want him, you know, he would be a great asset. So the soldiers came across Archimedes, and there he was working on his mathematics. And there's warfare going on all over. The Romans had finally gotten into the city, and here they were, you know, right there by him, and they cast a shadow on his work. And he said, "Do not disturb my circles." And the soldier ran him through with a sword, and Archimedes died, and that's it. And so Sophie, what this did in terms of Sophie Germain is she read the story, and she thought, oh my goodness, if that's how amazing mathematics is, that somebody wouldn't even care about their own life, but that they would keep doing mathematics when a soldier is right there with a sword threatening them, I've got to find out what this mathematics is all about. So, as well as talking with you about the obstacles that these mathematicians had to overcome, or these people had to overcome in order to become mathematicians, I'd also love for you to pay attention to what inspired them. So what inspired Sophie is the story of Archimedes, that math was so compelling to him that he didn't have a care for his own life as he was immersed in mathematics. As she began to study mathematics at home, her parents did not approve of this at all. It was thought during this time that if women studied mathematics or science, these abstract disciplines that were so hard, that they would go crazy, that it would break their minds. So her parents did not want her studying mathematics. So she would study mathematics when they couldn't see her. After everybody went to bed at night, she would use the fire in her room that was lit to keep warm, and she would use the light and the warmth of the fire to study her mathematics. Well, her parents figured out that she was doing this, so they did not allow for a fire to be lit in her room in order to keep her in bed instead of studying mathematics. And so Sophie started to sneak candles into her room in order to use those for light and warmth. So then they took away her clothing so that she couldn't get out of bed because it would be too cold. So she just wrapped herself up in her blankets, and she just couldn't stay away from mathematics. She found it so compelling. And one morning they found her at her desk asleep, and the candle had burned all the way down, and the ink was frozen in the inkwell. And her parents finally decided, okay, we're going to let her go ahead and pursue this. She had no teacher, she had no tutor. She was studying alone in her room at home. When she was 18 years old, it was just after the Reign of Terror, 1794, During the Reign of Terror, 40,000 people had died in prisons and by the guillotine. And so that left France with not many scientists and engineers. So an emergency council was set up, and they created a new school, which came to have the name École Polytechnique. And this building right here is the building that first housed the École Polytechnique. So this is just off of the Place de la Concorde. 1794, she wanted to attend school so desperately. She wanted to go and take classes there, but of course she couldn't sign up because she was a woman. But back in the day, professors would have their notes printed up and they would sell them so people could get access to the notes. And we're not sure exactly what happened in Sophie's case, if another student brought the notes to her or if she actually purchased these published notes. But somehow she got a hold of the mathematical notes of Lagrange. And he was teaching calculus. And at this time, late 1700s, calculus was still coming into its own. It was not entirely codified at this point in time. And Lagrange was teaching his own version of calculus, which was based on Taylor series polynomials and just had his own version. And what happened at the end of the semester, the thing to do in that day was that the students would write up their survey or their comments about the course. And so Sophie was getting these notes. She was actually turning in homework, but not under her own name, of course. She took on the name Monsieur Leblanc. And Monsieur Leblanc had been a student at the school. There was a student by that name, Augustin Leblanc, and he had recently resigned as a student, dropped out of school, and she took on his name. He may have been a family friend, we don't know. So she submitted her commentary at the end of the course through someone else, and Lagrange wrote this, and it stood out above all the rest. So here's a person who's never had a teacher, never had a tutor, studied from the books in her father's library. She had no way of knowing what order she should progress through these things. She turns in her survey of this course, and Lagrange is just blown away, absolutely blown away. He needs to meet this person, Monsieur Leblanc. Well, so Sophie agreed to meet with him, and of course her cover was blown. What happens now? Lagrange was so amazed, it didn't matter to him that she was a woman. He started to, between her young age, her lack of training, the fact that she was a woman, the level of work that she was doing, he told everybody about her. All the scientists and mathematicians in Paris of the day wanted to meet Sophie Germain. She had lived a totally isolated life for 18 years, and all of a sudden, all of the mathematicians and scientists in Paris wanted to be presented to her and get to meet her. So that was rather overwhelming. It was not only overwhelming, but they kind of didn't know what to do with her. So a mathematician came to her, and he had authored an elementary book on mathematics, and he gave that to her as a gift. And here she was doing the most advanced calculus of the day. So that was rather disconcerting and sort of insulting. So he tells his friend, the astronomer Lalande, he says, oh, you need to meet Sophie Germain. So Lalande goes to meet Sophie, and he brings with him also a book to give to her. And the English translation of the title is basically Astronomy for the Ladies. So a very watered down astronomy book. She was so insulted, she never spoke to him again for the rest of her life, because it was such a patronizing experience. So others were giving her their work as well, but it was so haphazard and unorganized. She never really did have a teacher or a tutor or a course of study. In the early 1800s, she read a book called Disquisitiones Arithmeticae, which was written by Carl Friedrich Gauss. He wrote it when he was about 21, published it when he was about 24. I mentioned earlier that we like to rank mathematicians. In terms of top three, he's up there with Archimedes. He's always in the top three. We've got Archimedes, Gauss, and Sir Isaac Newton. Okay, so this was quite somebody. She read his book. It was the first text on number theory. Prior to this time, number theory was just a collection of conjectures and theorems that were here, there, and everywhere. And he gathered it all together and developed some of his own, and it was the first text on number theory, which was something that she was very interested in. Well, he's from Germany. He doesn't know what's going on in Paris. He is the greatest mathematician of the age. She wants to correspond with him, so she goes back to her pseudonym of Monsieur Leblanc. They had a wonderful correspondence, just phenomenal, going back and forth about very advanced mathematical ideas. At one point, about 4 years into their correspondence, there were French troops that were surrounding the town where Gauss lived in Brunswick, Germany, and Sophie was very concerned about Gauss. She cared about him, but think about why else she might have been concerned. Her inspiration was the story of Archimedes, who was killed when his city was invaded, so she was very concerned for Gauss. Because of her family connections and the wealth of her family, she did know the general who was, in charge of the invading force. So she got a message to the general, and she said, "Would you please make sure that Gauss is okay, that Gauss is safe?" So the general sent a messenger to Gauss to check in with him and said, "Hey, are you okay? And we're going to protect you. We're not going to bother you." And the messenger said, "Well, this is Sophie Germain from Paris." And Gauss is like, I don't know, the only woman I know from Paris is Mademoiselle or Madame Lalande. He didn't know a Sophie Germain, so he just kind of passed it off. But about 3 months later, Sophie came clean, and she told him who she really was. And he also responded very well. And I hope that I've included in my slides a quote from his letter, because he just heaped praise upon her. Greatest mathematician of the age. So I want to talk a little bit about the work that they were looking at together. So I put recall up here because this equation, I hope we all recognize. It's the Pythagorean theorem, a squared plus b squared is equal to c squared. And that equation relates the sides of a right triangle. So if I know that this has length 4 and this has length 5 and this has length 3, if this is actually a right triangle and I plug it in, then that equation is going to work. The problem that she was focused on in number theory is called Fermat's last theorem, and it looks a lot like this in structure. Instead of a, b, and c, we have x, y, and z. The exponents are all the same, just like those are all squares. This is all n. But n has to be greater than 2, so it's cubed, or to the 4th power, to the 5th power. And the conjecture was that you could not come up with a true equation if you were plugging in positive integers and raising them all to the 3rd power, all to the 4th power, all to the 5th power. This is a conjecture that actually stayed open for 350 years. It was first proposed in the 1600s by Fermat, and it was finally proven in the 1990s, a guy by the name of Andrew Wiles, who is still living and active, and he's in Oxford and still publishing. So when Gauss found out that he was corresponding with a woman rather than Monsieur Leblanc, he wrote back, and I know this is a lot of text, but I'm going to read through it. "How can I describe my astonishment and admiration on seeing my esteemed correspondent, Monsieur Leblanc, metamorphosed? When a woman, because of her sex, our customs and prejudices, encounters infinitely more obstacles than men in familiarizing herself with number theory's knotty problems, yet overcomes these fetters and penetrates that which is most hidden, she doubtless has the most noble courage, extraordinary talent, and superior genius." That is the greatest mathematician of the age, writing to Sophie Germain. After about 5 years, their correspondence did fall off. It wasn't because he lost interest or he lost respect for her. He maintained profound respect for her throughout life. But Gauss was involved in a great many things. Just around 1809, he moved from Brunswick to Göttingen. This observatory had just been built, and it was built with him in mind. He had rooms over here on the left in this picture, and so he would get so heavily involved and so interested in what he was doing that he would kind of just drop other things and forget about other things. Here's the observatory from the back, so you can see his rooms over on this side. But that was okay. You know, Sophie had never had a tutor or a teacher, and she just continued working on her own in adulthood. She began to correspond with another mathematician by the name of Legendre, who was also a number theorist. This is the street Sophie lived on in adulthood. And this door closest to us is her house. After she died, for quite a long time after she died, because she hadn't actually published herself, she was corresponding with other people, Legendre had written a book, and he had a footnote to Sophie, and it was thought for a long time that she just really was a sort of a minor collaborator with others. But it actually turns out that she contributed more to Fermat's last theorem, to the solving of that, than anyone else in a 100-year span of time, from 1738 to 1840. So again, a picture of her house. To speak to Gauss's ongoing honor and respect for her, he petitioned the University of Göttingen to give her an honorary doctoral degree for her work, and this was in 1831. And unfortunately, she developed cancer and she died before she could be presented with an honorary doctorate. This is a small sculpture of Gauss. I know that you can't see that very well. So Sophie Germain, 1776 to 1831. She's buried in Père Lachaise Cemetery in Paris. And I just need to say a little bit more about her work. She not only did work in number theory, but she did work in elasticity. And there's a long story behind that, but I'm looking at my time and realizing if I'm going to talk about 3 mathematicians in this much detail, I'm going to go past the hour, so I'm going to hold myself back a little bit. But her work on elasticity is part of what allowed something like the Eiffel Tower to be able to be built. And I hadn't known this before I traveled, but on the first level of the Eiffel Tower, there are names of prominent mathematicians and scientists. We see Lagrange, who is the one that she got the notes from. We see Laplace, whom we're going to hear about later. We see de Prony, who was one of the first professors at École Polytechnique. We see Cauchy, who was instrumental in making the calculus rigorous. Her name is not there, and yet her work is significant in the structure even being able to be built. So I'm just putting this last beautiful slide in there in honor of Sophie Germain, because we really need to honor her when we look at the Eiffel Tower and think of the Eiffel Tower. So moving on to the next mathematician that caught my attention, we have Sonia Kovalevskaya. She came quite a bit later. She was born in 1850, and she was born in Moscow. And this was right around the time of the Crimean War. So Crimean War started 1853. She was born in 1850. In her childhood, she had an uncle. So I want to share with you, with each one of these women, what was their inspiration. Why would they persevere against the obstacles in their families and in society to study mathematics? Who wants to study mathematics that bad, right? But she had an uncle, Peter, when she was young, and he liked to read about science and math, and she loved him, and she would kind of hang on his knee and listen to him, and he would tell her stories about puzzles of the ancient Greeks. One of them is known as squaring the circle, whether they could do that with a compass and a straight edge. Another story was that of having an asymptote, which means you've got a line and there's a curve approaching it closer and closer and closer forever, but never crossing it. And I don't know how your brains worked when you were children, or if there are little kids around you that ask questions like this, but things like, is there a biggest number, or do they just keep going? Is space infinite? You know, this is the sort of thing that was going on in her mind, I think, as her uncle was talking to her about this curve getting closer and closer to this line, but never touching it, but always getting closer forever. And that inspired her. a very unusual thing inspired her. When she was approximately 10 years old, her family moved from the city out to their country estate because after the Crimean War, there was talk of liberating the serfs, and they wanted to get out to the estate, make sure everything was going okay. They did not order enough wallpaper to paper the whole house. Well, I mentioned about Sophie that professors published their notes, and you could purchase these. Well, her father had lecture notes from his student days, and when they ran out of wallpaper, they wallpapered her bedroom with his calculus notes. And Sophie was, or Sonia, I may go back and forth. I'm not making a mistake when I call her Sophie. I'm not thinking about Sophie Germain. Sonia, they called her Sonia, they called her Sophie, they called her Sophia, they called her Sonieczka. So you may hear me saying Sonia, you may hear me saying Sophie or Sophia, but Sonia Kovalevskaya. She was absolutely drawn by this. She would try to figure out what it was saying. She would try to figure out what order. It was like a puzzle. What order should these pages actually go in? And that may seem kind of odd. I think if we saw a bunch of math pasted on the wall, you know, we might run away instead of standing there for hours trying to figure it out. But I think back to my first experience with J.R.R. Tolkien and The Lord of the Rings, and you've got this map over here of a different land, and you have this different language across the top and these runic letters, and I wanted to know about that. So I went to the appendices of his book to try to figure out this language that he had created. And I remember as a kid loving secret codes, you know, that my friends and I could write things and our teachers and our parents wouldn't know what we were writing because we had this secret code. I think for Sonia, what this was on her wall, it was kind of a secret code with these, you know, limniscots, these 8s lying on their side, these elongated S's, all of these different symbols that she didn't know the meaning of. So I did not get to travel in Russia, where she lived, and I also did not get to travel in Sweden, which is where she eventually got a position as a professor. So I don't have a lot of pictures to share for Sonia, but I'll just talk a little bit about her life. Her family was back in the city in the 1860s, and I don't know, I wonder if every century, the 60s are kind of the decade of freedom or something. This is just after the Crimean War. The young people especially were looking for change. They wanted to change the lot of the serfs. They wanted to change the lot of the common people. There was a need for improvement in science. They really looked towards math and science to improve the lot of the people. So the young people, men and women, were wanting to be educated. She could not attend school. She could not go to university. So what was open to a young woman of the time, and of course her father wasn't going to sign off on her being able to travel elsewhere to go to university. So she entered what's called a fictitious marriage. In other words, a nominal marriage, a marriage in name only. There was a young man who was a paleontologist. His name was Vladimir Kovalevsky, and he married her, which enabled her to travel. And she traveled to Germany, she traveled to Heidelberg, and she went to the university there. Things were a little bit easier in Heidelberg than they were in Russia, but she still could not enroll in the university. She still could not officially take classes. In fact, she couldn't even audit classes unless she had specific permission from the professor. So she had to write to the professors, explain her situation, and say, will you please take me on? Will you let me audit your course? A number of them did. Some names you may recognize, Kirchhoff, von Helmholtz, Bunsen. You know, in our science classes, we have Bunsen burners. He was one of her teachers. She studied here for 3 semesters, worked very diligently, and proved herself very well. The professors were all very, very impressed with her. So I just include some of the sites she would have been familiar with. Heidelberg Castle that dominates the landscape. and then looking across the river from the castle, there is a path on the other side known as the Philosophenweg, or the Philosopher's Way. So these are the places she would have seen, the places she would have walked. It's called the Philosopher's Way because the professors and the students would go up there and walk and talk about ideas. So the Philosophenweg. Here's the door to the university, the library of the university, and the seal of the university. Heidelberg really didn't have enough to offer her mathematically, so she ended up traveling to Berlin to study under Karl Weierstrass. He was involved with analysis, calculus. He's known as the father of modern analysis, and she studied under him. Actually, when she traveled to Berlin, it was harder for her to break into the academic world there, even though she had just glowing letters of recommendation from her professors in Heidelberg. One reason, possibly the main reason, is that she was a woman. But another reason is that there were a number of women coming from Russia into other places in Europe wanting to get an education. And there was concern about their political leanings. So it wasn't just that she was a woman, but being from Russia, she was probably a radical. So they weren't so sure about having her in the university. This actually turned out to her benefit. And Weierstrass at first wasn't so happy to take her on. He gave her a page of math problems and told her to come back when or if she had solved them. She took them home, solved them all in about a week, and had come up with unique ways of solving things that he had not seen before. So even though he was not necessarily someone who was promoting, equality of women, he couldn't let her go, someone who had this much talent. Because the university would not let her enroll, he took her on as his private student. She came to his house every Sunday, and they worked together. And he maintained throughout his life that she was the best student that he ever had. During her time with him, she wrote 3 papers. He considered each one of them worthy of a doctoral degree. She wasn't, of course, going to get that in Berlin, so he petitioned a place we've already heard of, the University of Göttingen, and asked them to consider granting her a degree, which of course was very unusual. She hadn't done any coursework there, she hadn't taken any tests there, hadn't given a verbal defense of her dissertation there, but based on the merit of her work, she was granted a doctorate in mathematics, and she is the first woman in Europe to have been granted a doctoral degree in mathematics. So there's a lot to say between this time and the time that she did end up getting a professorship. It took a very long time for that to happen. Her marriage was closer and further apart. She and Vladimir had a lot of disagreements with each other. They kind of didn't understand each other very well. They did eventually fall in love. They had a child together, moved back to Russia, lived there for a time. But he was very moody, and his mood swings became more pronounced as he got older. He got into some really bad business dealings, went bankrupt. They separated, and eventually he committed suicide. So it was a very, very difficult situation. After his death, she threw herself back into mathematics. A fellow student of Weierstrass named Gösta Mittag-Leffler was really, really impressed with Sonia and really wanted to see her get a university position. Prior to this time, Weierstrass had tried to get her a position as well. And all that would be offered her in Berlin was teaching elementary school, teaching at the elementary school. She had written 3 papers, three doctoral dissertations. And her comment was, I never was very good with the multiplication tables. So she didn't take that job. Eventually, Gösta Mittag-Leffler was able to get her a position in Stockholm. She always wanted to have a position in Russia. She loved Russia. That was her home. But the universities just never opened to women teaching in Russia. And also the academy, the Imperial Academy there, did not admit women. But there was a Russian mathematician, Pafnuty Chebyshev, who was also so impressed with her work and pushed so hard for her to be accepted into the Royal Society there that they changed their bylaws in order to allow women to get in, and she was elected to the Imperial Society of the Royal Academy there in Russia. So she did teach in Stockholm. She did much amazing work. She worked particularly with partial differential equations. Unfortunately, she died after about 2 years. So when she got a position, what that means, she was allowed to teach. She was what's called a private docent, which means, hey, we give you permission to teach at the university. Isn't that great? But we're not going to pay you anything. So you have to get students to want to listen to your lectures, and you have to get them to pay you. But you can give lectures here. After that, she was eventually promoted to Professor Extraordinarius, which is just below Professor Ordinarius, which didn't make any sense to me until I realized that Professor Extraordinarius means professor without a chair. Professor without a chair. So you're like an assistant professor, and then if you become a Professor Ordinarius, then you actually get a salary. Okay, she was not able to really care for herself very well. She became ill while traveling to visit friends. There were issues with the train. She got stuck in a train station overnight. She ended up developing pneumonia, got back to Stockholm. She declined, and she ended up dying at the age of 41. So, yeah, on that sad note, I'm going to move on to our next mathematician, Mary Fairfax Somerville. So we're going to travel from Stockholm over to Scotland, in the area of Edinburgh, and just north of Edinburgh, Burnt Island is where she lived as a child. She was actually born in Jedburgh at the home of an aunt and uncle. So I want to talk about her inspiration as well. So I always want you guys to be thinking about what inspired them. Why did they persevere against all these odds in order to pursue math of all things? This is a little map in the city center of her hometown. You can see how proud they are of her. She's the only person that's pictured on the town map. That's Mary Somerville up in the top right-hand corner. Her home was right about here. She spent a lot of time in childhood on the links. That might sound like a golf course. It's not. It was just an open green area where the people of her day would graze their cattle, or they would come out and walk around and be out in the natural world. There's a beach right here. She spent a lot of time on the beach. So here's a picture of the links. This is looking south. You can see Scotland's capital, Edinburgh, here. These are very characteristic hills of Edinburgh. She spent time on the links, down on the beach. There is a tide pool over here that she spent a lot of time exploring. She checked out the wildlife in the tide pool, the shells, the rocks. She walked along the beach, probably dressed a little differently than I was, but my goal in my travels was to really walk in the footsteps of these mathematicians, and I did that as literally as I possibly could. She would walk the beach collecting stones, observing the birds, observing the waves, picking up shells. This was a significant part of her inspiration, being out in nature. It really got her excited about science and eventually about mathematics. This is the home that she grew up in. Her family was not wealthy, but they were well connected. So her maiden name was Fairfax, Mary Fairfax, and her father comes from the Fairfax family in Scotland, and her mother was also connected to some well-known Scottish houses. The other inspiration that she had, as well as the beach, was looking out her window at night at the stars. I'm not sure which of these windows was her bedroom window, but there's the front of the house and there's the back of the house. So I've got it covered one way or the other. I know she was upstairs and she was looking out the window at the stars. She was born, there was a house here that she was born in. Her uncle was the minister at this kirk, this ruined abbey, and so the parsonage or the manse was here, and that's where she was born. This was ruined already in her time, but they were still holding services there. Every so often, her family would come down from Burnt Island. I have to tell you, her father was away at sea at the time that she was born, which is why her mom was with relatives when she was born. Her father was a vice admiral. This was in 1780, so it was the time of the American Revolution, and they're British, but we'll try not to hold that against her, okay? So every so often they would come back and visit, and this is very different territory for her, very different from the beach where she lived, but she loved it. She loved the change of scenery, seeing the different foliage, and the different soils and rocks that she would see here. She and her cousins and her aunt would bathe in the Jed water. This is the Jed water in Jedburgh. But she spent most of her life in Burnt Island. She and her mother were often invited to go to tea parties, which were quite boring for her. But at one of these tea parties, she met a girl who was a bit younger than she was. And this girl invited her over so that she could show her like her fancy sewing, her fancy stitchery. While she was visiting this girl, whose name was Miss Ogilvy, she saw some women's fashion magazines sitting there, and they started going through these magazines together. And on one of the pages, there was a little math problem, which is kind of interesting. It's sort of mixed messages, right? You tell women that they can't study mathematics, and then you stick a little math problem in a women's magazine. Seems like sort of mixed messages to me. But anyway, just this one problem. She turned the page, and there were X's and Y's in it, not just numbers. And she was intrigued. What is this? And her friend, Miss Ogilvy, said to her, well, it's something that's called algebra, but I don't know what it is. And Mary was just dying to find out. So she went home. She looked through all the books in the house. There was one on navigation. She thought that that one might be helpful, but it turned out that that didn't help her either, but it never left her mind. What is this thing algebra? I want to know about this thing algebra. And what she says about it, she knew that she couldn't ask anybody about math. It was just part of society, and it was part of her family. Unfortunately, not one of our acquaintances or relations knew anything of science or natural history, nor, had they done so, should I have had courage to ask any of them a question, for I should have been laughed at. I was often very sad and forlorn, not a hand held out to help me. No help. She wanted to learn algebra, and there was nobody to help her. When she was about 13, her family started wintering in the big city of Edinburgh. So they would spend their summers in Burnt Island, they'd spend their winters in Edinburgh. So a few pictures of Edinburgh. Here's Edinburgh Castle, and here's the National Gallery, which was during her lifetime. It wasn't there when she was an early teenager, but it was there during her lifetime. St. Giles Cathedral. So while in Edinburgh, although she couldn't learn mathematics, she was allowed to learn painting. And she studied under a painter who became quite well known, Alexander Naismith. And he was known as a landscape artist. He's also known for painting a portrait of his friend, Robert Burns. Robert Burns asked him to do this portrait so that he could use it in a book of his poetry. And if you've seen a picture of Robert Burns, this is probably the one that you've seen. It's actually a very small portrait. It's this one way over here that you probably can't see very well. And when I went in, the docents of the museum said to me, you know, everybody who comes in here wants to see that one. Right? It's kind of like going to the Louvre and everybody wants to see the Mona Lisa when there's all this other stuff as well. The way this ties into Mary's story and what this has to do with mathematics is that one day, as she was in the studio doing her painting, she overheard Alexander Naismith saying to another group of students, well, if you want to learn more about perspective, you really need to study Euclid. You really need to read Euclid. And so Mary files that away to Euclid. That's what I need. I need Euclid. But again, she goes back home, she has no access. Actually, not only did her family not know science or mathematics, but as a woman, she couldn't go to a bookstore and buy Euclid's Elements. However, her brother eventually had a tutor who was hired for him. Now, the tutor wasn't necessarily good at math. He was more about languages and philosophy. But Mary was able to talk the tutor into buying her a copy of Euclid's Elements. So she got this copy of Euclid's Elements, and this story is similar to Sophie Germain. She starts studying it. Her parents don't like it. So she starts studying it in her room at night. She's sneaking candles out of the stores, and the servants are the ones that gave her away. They're like, we keep running out of candles because Mary's using all the candles. So then Mary has no access to candles, and she can't keep studying. But she had studied the first 6 books of Euclid, and so she would lay in bed at night and go over them in her head, is how she would do that. So, yeah. I'm kind of rushing, and I want to make sure I don't leave out any big parts of the story that I want to share with you. But you know, time passes. She was quite a beautiful woman. She was known as the Rose of Jedburgh. Rose of Jedburgh. She was very beautiful. There was no portrait made of her until she was, I would say, mid to late 40s. So this is her portrait that's in the National Portrait Gallery. And she was considered quite a beautiful woman. Her daughter says of her that she remained beautiful even into old age. She lived to be 91, and she was considered beautiful throughout her life. And if you read her recollections, Mary herself actually talks about this. She talks about beauty, and that sounds a little bit arrogant. She actually wasn't an arrogant person at all, but this was a very important thing at this time. Remember that her family was not wealthy, didn't have money. So for her to be okay, she was going to have to marry well. And being beautiful kind of helps with that, okay? So she gets married. She marries a cousin of hers. His name was Samuel Grieg. He was in the Navy. They moved to London. They have a couple of kids. 3 years into the marriage, he dies. She's widowed. She moves back up to Scotland. And she's really devastated. She truly loved him. She's devastated. She's in grief. But she's also inherited quite a lot of money. And she's now respectable because she's a married woman who's been widowed. So she's got some freedom. What does she do with it? She studies mathematics. She gets connected with a couple of professors at the University of Edinburgh. John Playfair is one of them, and she probably got connected with him because he was born in Burnt Island. So they probably had the same social circles. It's a pretty small place. He connected her with another mathematician there by the name of Wallis. And John Wallis suggested to her, she was trying to read Newton's Principia Mathematica. Here she is around 30 years old. She, hadn't even known what algebra was. She had just read some of Euclid on her own, and she's trying to read Sir Isaac Newton's great work. So Wallis gave her some suggestions of books that she should purchase and read, and she was able to do that. And what she says of this in her recollections is the following. I could hardly believe that I possessed such a treasure when I look back on the day that I first saw the mysterious word algebra and the long course of years which I had persevered almost without hope. It taught me never to despair. The span of time here is 20 years. She first came across the word algebra when she was 13, and she wanted to learn algebra for 20 years. Finally, when she was 33 years old, she had her little library of mathematics books, and she could finally learn. She did get married a second time. It was to another cousin on the other side of the family. This was a cousin who had grown up in Jedburgh, and where I showed you the pictures of earlier. And this was Somerville, who she married, hence the name Mary Somerville. He was an inspector general of the Army Medical Corps in Britain. They moved to London. He was also an explorer. He did a lot of exploring in South Africa. He was a scientist, and he became a fellow of the Royal Society. He was elected to the Royal Society all of a sudden, Mary was in touch with the leading circles of science. She wrote a paper on, I'm forgetting the title, but it had to do with magnetism and solar radiation, and it was published in the Proceedings of the Royal Society. This was in 1826. A few years later, a member of the Royal Society came to her and asked her if she would do a translation of Celestial Mechanics by Laplace from the French into the English. And she thought about it and she worked with it for a while. She did so. She did such an excellent job in the way she translated it and in the notes she added in that it was, I mean, maybe a bestseller isn't the right word to use, but it was very, very popular and went through many editions. So it was really amazing. Not long after that, she wrote a book called The Connections of the Physical Sciences. This book was reviewed by William Whewell, who was the master of Trinity College, Cambridge at the time. And in his review of her book, it's the first place that the word scientist is ever used. He coined the word scientist as he was doing a review of her book. So all of a sudden, kind of like Sophie Germain, here she is at this point, what is she, in 1826, when her first paper is published, she's 46 years old. And she finally comes into her own. She and her husband were invited to come to Trinity College, Cambridge, and it was with such enthusiasm. They received a letter from Adam Sedgwick, and he said, you know, this professor is away from his rooms right now. You can use his rooms. We will bring in a 4-poster bed. We don't usually have accommodations for women because this is usually very monastic. The professors who had rooms here, they were all bachelors. You couldn't live in room in the college if you were married. So they brought in a bed for them, and he wrote, "We have no cannons at Trinity, but if we had cannons, we would shoot them off in honor of your arrival." I mean, this was really a big deal. That's how celebrated she was. So just another image of Trinity College and the great court there. Not only that, but let's rise a little bit higher. Her book, The Connections of the Physical Sciences, was so popular that the Duchess of Kent asked for a copy. This is Kensington Palace. The Duchess of Kent lived there. The Duchess of Kent was the mother of Queen Victoria. At this time, Princess Victoria. Mary Somerville was invited by them to come. She gave them a copy of her book. They talked. She had a private audience with just the Duchess of Kent and Princess Victoria for half an hour, just her and the two of them. A couple years later, she saw Queen Victoria crowned in Westminster Abbey. She writes about that as well in her recollections, how wonderfully, beautifully she thought Victoria did for such a young person to be going through such a ceremony, that she did seem very regal. It's kind of interesting. I wanted to share this. When I was in the National Portrait Gallery in Edinburgh, I walked around a corner, and here were these two pictures right next to each other. It was a display of women from the 1800s who had, you know, achieved sort of beyond their circumstances, beyond the circumstances of women at that time. This is Mary Fairfax Somerville. This is Queen Victoria, and their pictures are right next to each other in the National Portrait Gallery. So that is the story of Mary Somerville, who pursued her dreams, never gave up, and once she was finally in her 30s, got to study what it was that she wanted to study, and really had an impact. There is a college in Oxford that's named for her, Somerville College. And I've got about 5 minutes to talk about Ada Lovelace and Emmy Noether. And I've put the slides in the order I have because Ada Lovelace, and that name Byron is not just a coincidence. She's the only legitimate child of Lord Byron, the poet. The Byron family was friends with the Somerville family. And Mary tutored Ada. Ada has a little bit of a different story in terms of how she got into mathematics. Lord Byron left Ada's mother when Ada was an infant and never came back. Ada never knew her father, had no recollection of her father, and her mother was so angry at her father. I mean, he was a woman. I love his poetry, but just a womanizer, you know, just not a very wonderful person, or certainly not a wonderful person to be married to. So Ada's mother would not let her read poetry. She wanted Ada to study math and science to keep her mind balanced. And I've actually read a letter from Ada's mom to Mary Somerville that thanks her for the tutoring that she's doing of Ada, and it uses that word, balance, to keep her mind balanced. And Ada took to it. She didn't rebel against it. And she became an excellent mathematician. She became connected with Charles Babbage, who was also at Trinity College, Cambridge. He developed some computing devices. His vision for the computing devices is that they were going to crank out numbers like a calculator. They were going to crank out tables of logarithms and trigonometric functions. Ada had a bigger vision. She had a vision not of a calculator, but of a computer. She felt that this was something that could be used to compose music. She wrote a program for this to generate Bernoulli numbers, and that is actually considered the first computer code ever. Ada wrote the first computing code ever. Unfortunately, she developed cancer. She died at the age of 36, same age that her father died. To the horror of her mother, she requested to be buried with her father up in the church in the Byron Vault up in Hucknall. So this is the church where Lord Byron and his daughter Ada are buried. Boy, I wish you could see that better. There's a plaque on the floor here to Byron. There's a plaque up there to Byron. There's a plaque over here to Ada. And right here, this light that's shining up, that's a wreath that's above the crypt that's down below. It was a wreath that was laid there when Byron died, and they've preserved it. And they flip a little light switch on, and so you can see it better. It's really cool. And then there's a little opening over here where you can look down, and you can actually, it's hard for you to see, but you can actually see into the crypt. If you're curious, you can come up later and you can look at it on the computer screen. Babbage called Ada the enchantress of numbers, and this is a little something outside the church that they've put together to honor her. But her work would have been forgotten. It would have been sort of subsumed under Babbage's, except for Alan Turing, who also went to Trinity College, Cambridge. He read Babbage's papers, and along with them read Ada's papers. And it was part of his inspiration. Does anybody recognize this? Where this is? This is Bletchley Park. What was that recent movie with Benedict Cumberbatch about the Enigma code? I'm gapping out on the name of it right now. But this was, breaking the code here at Bletchley Park during World War II. They used computers to do so, and Ada was part of Alan Turing's inspiration. The reason we know of her today is because basically 90 years later, he rediscovered her. I'll say a little bit about Emmy Noether, who was in Göttingen. Klein and Hilbert, famous mathematicians of the day, recognized her genius, wanted her to be part of the university, part of the faculty. Even at this time, which is about the time of World War I, they were not allowing women to teach. And Hilbert fought for her. What Hilbert would do, finally, he said, the academic senate said to him when he tried to get her on faculty, they said, "What are our boys going to think when they come back from the battlefield and have to sit at the feet of a woman?" And he said to them, "Mein Herren, this is a university, it is not a bathhouse." But his argument did not help. She did not get a position, at least not initially. So he would sign on to give lectures, and then he would have her give the lectures instead of him. So it was like it was being taught by him, but she taught instead of him. She eventually was allowed to be a private docent, which again meant she could do the work. She could teach, but she didn't get paid for it. She was actually, just after World War I, the center of a ring of the most, I don't know about the most important, but really, really significant mathematics research that was going on at that time in advanced algebra or modern algebra. In fact, it's to the point, those of you that have taken modern algebra, advanced algebra, you'll get this title. She was called the Queen of the Rings. The Queen of the Rings. So these are pictures of the Mathematics Institute in Göttingen. This is inside with their models collection. Eventually, Hitler came to power. 1933, Hitler became chancellor. Noether was Jewish. She ended up having to leave. She came to the United States, Bryn Mawr University, and she developed an illness that she needed surgery for, and she unexpectedly died a few days later at the young age of 53. Einstein wrote a glowing obituary of Emmy and how important she was and how important her work was. And yet here are the men of the academic senate in Göttingen saying, what are our boys going to think if they have to sit at the feet of a woman? So let me end by telling you, if you're interested in the sorts of things I've been talking about, I did keep a blog as I was traveling. It's easy to remember if you write it down and lose it. It's MathSab, which stands for Math Sabbatical, .blogspot.com, and you can find information about my travels there. So thank you for coming. Yeah, question?
Tell us what your inspiration was to become a mathematician.
Oh my goodness, you know what? Thank you for asking that. It's a really long story, but it wasn't, okay, here's the deal. Let me start with the non-inspiration and go to the inspiration. I did not sort of choose to go into mathematics. I went into computer science. This was in the early 80s. My high school I'd never seen a computer in my life. That's how old I am. So I went away to college. I was going to be a computer science major. Math is a really good minor. I decided computer science wasn't for me, and the only way that I could still graduate in 4 years, which my father had told me I needed to do when I left for college, was to change my degree from my major to my minor, which was math. I did not want to be a teacher. I didn't know what else to do with mathematics, but I was stuck. Once I got out and started teaching, someone asked me to coach students for a competition. And competition problems are like riddles and puzzles. And that started getting me excited about mathematics. And then I went to a conference and someone came and spoke about a topic in math called fractal geometry that I had never heard of before. And it was amazing and beautiful, and I was hooked, and I adore mathematics. It is my passion. But I went into mathematics not wanting to be in it, and it became my passion later. So thank you for that question. Are there other questions?